Hello from the 2010 NPRA National Safety Congress. My name's J.B. Avance. I'm with Penn Energy's Oil, Gas, and Petrochem Equipment. And we're here today at Safer Systems for an announcement of an industry first that goes with their chemical emergency management solutions. With me today is James Gremillion with Safer Systems, and he's going to tell us a little bit about the company. Jim, how old is Safer Systems?
We're almost 30 years old. We started in 1981, and we've been doing the same thing that whole time, which is chemical emergency software.
Okay. Specific to the petroleum industry or widespread?
It's widespread. We do everything from alumina plants to chemical plants to refineries. We cover pretty much the gamut of any industry that has, manufactures, or even passes through chemicals that could be hazardous.
Okay. And you're based where?
In Camarillo, California, just north of Los Angeles.
And would you like to tell us a little bit just about what Safer Systems is announcing here today in San Antonio?
Yeah, we're announcing a new module for our real-time software. Real-time software is the package that we sell that handles events in real time, an event being a release of a chemical, an accidental release. The new module is called CAM, C-A-M, that stands for Combustion Analysis Module. And its purpose is to give us an analysis and resultant plume from any combustion that occurs, a fire, an explosion, anything where a chemical might burn.
Jim, that sounds really interesting, and I know that you're calling this an industry first. Can we see a demonstration of the CAM?
Yes, I have Eric Fishman here today, who's our engineering manager out of Camarillo, California, and Eric will be happy to demo software for you.
Perfect. Eric, J.B. Avance, Penwell.
Hey, J.B., nice to meet you.
And I understand you're going to be doing the demonstration for CamForce today.
That's correct, J.B. I appreciate the opportunity here to showcase our fixed facility emergency response application, Safer Real Time. The application is specifically designed for chemical plants and refineries. All the models that you're going to see today are also available in our municipality and hazmat responder applications. And in addition to the demonstration of Safer Real Time, I'm going to also show you the newest addition to the Safer Real Time suite, which is the Combustion Analysis Model. The CAM model enhances the already robust and powerful tools that we have in our application to provide a true powerful emergency response application. So the idle mode of the system, as we sit here, again, you can picture this possibly, JB, in your EOC. We have a complete visualization of the current conditions. We have wind speed, wind direction, ambient temperature. We even have displays for max wind speed and the current temperature that you can feel outside. A list of potentially impacted receptors, the downwind corridor, so you can visualize the possible impact zone. We display current readings from any gas detectors that you have integrated into the system. You can see here we have a multi-gas detectors on the map here. And we also have an alarm module in our tabs that allows you to see what sensors are in alarm. Okay, so should you have an event with a release and any of these sensors are in alarms, our software can kind of trigger a response for you. We're going to first run a release that is from the sulfur recovery unit at this particular refinery. It's going to be a vent gas coming out of a flare that's unlit. Okay, so to do that, we just go through our predefined menus. And the predefined menus are customized between our engineers and your refinery to make sure that we have all the scenarios for your facility built into the system. So we'll select the sulfur recovery unit. As you can see, we built the menu by process unit. It's completely customizable, however you want to set up the menus. It should be designed so that when you go to select a scenario in an emergency, it's easy to make the right selections and get to the proper scenario. So you'll see here we have a smart tab that shows you the case summary. This particular release is a 250 pound per minute release out of a 1 foot stack, 1 foot diameter stack at 100 feet in the air. I'll continue. And then we'll have to select the time it began, and we'll say 10 minutes ago. We're on the model. And it's Safer, runs its source calculations and renders the dispersion. You'll see pretty quickly here on the map that we accurately, well, as best we can, display the downwind impact zones. The colors that you see on the map here correlate to the user-defined isoplus, or concentrations of concern. Here for H2S, we've selected 0.1, which is a low-level odor threshold, as well as 30 and 100. These are the ERPG, Emergency Response Planning Guide, zones 1, 2, and 3 for H2S. Immediately, one thing you'll see on the emergency response screen after you run the scenario is a list of the impacted receptors. Anybody that's in the downwind impact zone, what zone they're in, and it also arranges them in order of distance from the release source. One of the really nice things that SAFER does for the user is it provides a comprehensive comprehensive report for you able to communicate within your incident command structure or to outside agencies, to your LEPC or to the responding agencies. We have the ability to do a point-by-point plume analysis, which will take the user through clicking on the map to determine what a specific location, maybe an intersection, what the concentrations are at any given location on the map. We can perform an infiltration assessment that allows you to choose a location on the map or pre-build it into the program, specific locations on the map, to produce a graph that shows you what the outdoor concentrations versus the indoor concentrations are. Okay. In addition, we also have a lot of other options that once you've run the scenario, you can export the plume to Google Earth. You can update the scenario as you have more information coming in from the first responders. And that's kind of the breadth of the tool when you talk about downwind dispersion. I want to show you the Combustion Analysis Module that's brand new with the version 10.1 release. Like I said before, the Combustion Analysis Model, it's a comprehensive tool that allows you to analyze the byproducts, both soot and chemical byproducts of a chemical fire, and allows you to view those products as they move downwind, just like our other model. And it gives a tool and a resource that first responders and refinery staff can use to make decisions about the response, as well as post-event analysis and decision making. We're going to run for our demonstration here a tank top fire, one of our new modules in the CAM model. And the tank top fire in this case would be something like refinery upset, or the roof on the tank submerges below the liquid, and the liquid either catches on fire or is ignited based on a decision made at the time. So now the output from our benzene tank top fire is displayed in terms of soot concentration at the ground level. So what you see down here is a darker colored area. That's the current concentration. The more opaque area is concentrations that have been impacted, like a footprint of the impact. The concentrations are in milligrams per cubic meter, so it's like a respirable or a breathable concentration of particulate at ground level. At the top you see a vertical cross section of the particulate. In this unstable atmosphere, you can see it raises pretty high off the ground. Next thing I want to show you is the particulate deposition. So the deposition, it would be the ground level per unit area coverage of the soot particulate. So a lot of times when there's a fire in a refinery or at a well blowout, you'll see significant coverage either on vehicles or people's homes, on their window panes, on their roofs. And a lot of times the refineries are on the hook for resolving these claims and getting them what they need to make sure that things are restored to their normal state. So when we look at the soot analysis and the deposition, our software calculates based on a gradient from low to high. You can see our software will calculate from 110 to 100, and those are customizable inputs as well. Calculate the ground level coverage of the soot. And so then you can use this in post-event analysis to determine valid claims and invalid claims and help you make that judgment at the time. Okay, now we're going to go back and look at the output from the byproducts of the combustion. So specifically the stoichiometric equivalence when you burn something, when you burn some sort of carbon particle, out of it comes something else. You mix air with carbon, you get carbon dioxide and water. The other end of that, the byproducts of the combustion model is displayed down here in the combustion smart tab. So in this particular case, when you burn benzene, you get nitrogen, carbon monoxide, hydrogen, carbon dioxide, water, and methane. And we can look at the concentration of any of those particular substances downwind in our gas analysis. So we're looking at the carbon monoxide output from this tank top fire, and you can see here, based on our concentration criteria, we have 25 ppm downwind at a significant distance for the carbon monoxide. So you're allowed this model affords you the opportunity to not only respond to a breathable concentration or deposition of the soot particulate, but also the byproducts of the fire that may be harmful as well. So that's the combustion analysis model, and appreciate the opportunity to showcase it for you, JB.
Well, I know that there's going to be literature available and brochures on the CAM system, and we appreciate the time that you've given us here at the NPRA, and we look forward to working with you again.
All right, thanks, JB.
Thanks, Eric.
Appreciate it.